Welcome to Engineering Campus, the place where I show you how to bring your idea to a product. And today I want to talk to you about solving problems. In the last steps we found out what we want to build, how we want to build it, and what kind of competition we have. And we were going into the function analysis to find out what kind of problems we have to solve, technical problems, to get to our product. And in solving problems we will now find solutions to these part solutions. So we name the functions found in the function analysis. We will note the physical laws that can be used we start just by the basics. The physical effect can be described with the physical law, which makes it possible to quantify the principle and thus compare numbers, so we can compare our solutions. And the physical effect is then further described via geometric or materialistic characteristic. So we solve it then practically. Here I have drawn an example. For example, when we have the function heating, we can describe it by the effect of Joule heating. We have the formula of P for the energy is equals to VA minus VB times E, which is basically the current going through it, and then the resistance, basically the difference is then radiating heat of it. This is the physical law and the physical characteristic, and this characteristic can then be shown in some kind of coil with a wire that then heats up and transfers electrical current into heat. Same is possible, for example, for pushing, where we have two effects, for example with gravity or with pressure, with the formulas regarding to it, and then we can use that effect to solve this function of pushing, and then in our product to have this effect. And same of course for increasing torque, where we have levers. So we have small torque with a small lever, and then we have a long lever where we then have fewer torque, but we can also turn it around, that we have a small lever and the long lever, and then we have on the long lever we just have to bring on few torque, and on the smaller lever we then have a lot of torque. And same is also valid with gears. Solving those functions needs a creative approach. Starting from principles makes it possible to approach a function neutral without preconceived solutions. Having a function solved by the most optimal solution can lead to a more efficient product. And having multiple solutions per function is also good, because then you have a backup if, for example, two functions don't really work with each other. An example, if someone thinks at a car engine, he automatically thinks he has to choose between diesel or gas engine, and then he thinks about, oh, how much PS and how many cylinders should I have. But by viewing the function neutrally, it is possible to come with a better solution. For example, an electric motor that is more efficient and needs less maintenance. So when solving problems, then a good copy is better than a bad invention. That means during the process you might find similarities to solutions from your competitors. Maybe they all solved a specific function the same way. You can have a new product just by breaking the cycle alone. So you can make almost the same product, but you just solve one function on a complete other way. Preferably better. But be careful not to break copyright laws. And otherwise, other than that, there are a lot of reliable techniques and methods already, so it's not necessary to do something new all the time. So keep it easy. For example, here vacuum cleaners, most of them use filters. It was possible to come up with a solution, and the centrifuge system was invented, like if you remember Dirt Devil. Now vacuum cleaners are copying this principle again, and you have a lot of these centrifuge vacuum cleaners. but they are still using electricity, design is the same, and everything else out of this design is still the same. So they basically just changed the centrifuge system, and they are very successful with it. So don't try to invent the next step, just wait for me to upload the next video, and see you then. Thanks.